This video we're going to be solving rational expressions, so you're going to see equal signs in it. Okay, so we're going to do the similar process. With these, there's two different routes you can go with it. One, getting them to have common denominators. My left side is missing 4. My right side is missing x minus 3. So I would get 4x on top. They would share a common denominator. And then if I distribute that one, it would just become an x minus 3. And they're sharing that common denominator because technically we're multiplying by x minus 3 over x minus 3 and 4 over 4. Whenever you have common denominators like this, they will cancel. So what you can see is if we do cross multiply here, I would get 4x times 4 times x minus 3 is equal to, I cross my other way, I have 4 times x minus 3 times x minus 3. So if I divide both sides by my 4x minus 3 over 4x minus 3, they'll cancel. And I have a 4x, equaling x minus 3 left, which is just my top. Okay, so in these situations when you have an equal sign, if you have common denominators, they will cancel, only when there are equal signs. Okay, so then if I keep solving, I would subtract x, I'd get 3x equals negative 3. I divide by 3, I get x is equal to negative 1. And then I need to check my answer to make sure it doesn't give me 0 in the bottom. So this is when we're using our exclusions or our restrictions. So if I take x minus 3 and I set it equal to 0, I get x cannot equal 3. Well, my answer was negative 1, so it's okay because it won't get me 0 in the bottom. Okay, so my restrictions for this one, x cannot equal 0. And now let's get them all to have common denominators. So we need them all to have 5x in the bottom. So he's missing 5, he is missing x, and he is missing 5. So I'm going to get 25 plus 3x is equal to 10. And then they're all over 5x. Okay, once they have those 5x's, they are gone. So I really have a 25 plus 3x equals 10, and I'm just solving. So I would subtract 25 from both sides. I'd get a 3x is equal to negative 15. Divide by 3, I get x is equal to negative 5, and then I double check to make sure that was not my restriction, and it was not, so that is a good answer. Okay, my next one here, he's missing d minus 2. He's missing the regular d, and he is missing both of those bottoms. So he's missing a d and a d minus 2. Okay, my bottoms would cancel, so if I want to go ahead and think about them not existing there, since I multiplied everything past my equal sign even, I would get a 2d minus 4 plus d is equal to, when I multiply all those, I get d squared minus 2d. Anytime I have a squared and another d, I'm going to factor. So I'm going to bring everything over and keep my d squared or my x squared positive. So I'm going to move everything over to the right side. If I combine these, I'll get a 3d. So I'm subtracting 3d over to this side. So I'd be getting a negative 5d, and then I would be adding 4. So multiplies to 4 adds to negative 5 is going to be a negative 4 and a negative 1. So I get d, when I solve my first one here and set it equal to 0, I get d equals 4. My second one, I get d equals 1. Now we got to check our restrictions. So this bottom here, when I set it equal to 0, I get d cannot equal 0. When I solve this other one, I get d cannot equal 2, which is neither of my answers, so it's good. Okay, another thing you could have done on this first one here is you could have cross multiplied this way and this way. Okay? My next one here, he's missing the n plus 3, and he's also missing n minus 1. This one here is just missing n plus 3. So I need to FOIL this before dealing with distributing him in. So when I FOIL him, I get n squared plus 2n minus 3. And then that n's still sitting out there, so I'll distribute him in. Anytime you have a GCF or a single thing sitting on the outside, always FOIL distributor box first and then send that little guy through. So it'll become n cubed plus 2n squared minus 3n. And I still got this plus 1 sitting here. Now if I distribute my other side, I get n cubed plus 3n squared. So if I subtract those n cubes, they're going to cancel from both sides, which is nice. I want everything to keep my n squared positive. So I'm going to bring everything over to this 3n squared because he's bigger than the 2 on this side. So I want to keep him positive. So I'm going to get n squared. I would add this 3n over to my other side, so I'd get a plus 3n, and I'd subtract that 1. And I actually forgot to multiply this guy by n minus 1. So going back up here, before we started moving everything over, let me reverse. There should be, in this spot right here, when I distribute that n minus 1, because that's what he was missing on the bottom, it should have been a plus n minus 1 here. Alright, so when I subtract, my n cubes will still cancel. I'm still going to move that 2n squared over, so when I subtract them, I'll still get a regular n squared. But this gets me a negative 2n. So really, I'll get a positive 2n when I add it, and then a plus 1. So multiplies to 1, adds to 2, is going to be 1 and 1. So when I solve them, I get n is equal to negative 1. And I double check my restrictions. So this one here, I'd get n cannot equal negative 3 when I solved him. This one here, I'd get n cannot equal 1 when I solved him. And mine was a negative 1, so he is good. Okay, my next one. Factor to see what you actually have to have in common. So I've got an n multiplies to negative 1, adds to 0 is n plus 1. And m minus 1. My other side here multiplies to negative 2, adds to 1 is 2 and negative 1. So I can automatically cancel off one set here because they share it. So this set is actually missing m plus 1, and this one is missing m plus 2. So I'll get an m plus 2 over here, and I'll get a 2m plus 2 over here. My bottoms will cancel because now they share them. So I'm going to subtract m and subtract this 2. And so I'll have a 0 left over here. 2m minus m just gets me m. I check my restrictions, so I go to my factored form. I get m cannot equal negative 1 and 1, and then over there a negative 2. Okay, my next one here, it looks like I got x minus 3s. He's missing x minus 3. He's missing the x plus 5. He's also missing x plus 5, so I'm going to have to FOIL that right side there. So I'm going to get x plus 5 plus x minus 3. When I FOIL or distribute or box, I get x squared plus 6x plus 5. We got to bring everything over to that one side. Let's go ahead and combine like terms to make it a little bit easier here. So my x plus x gets me 2x, 5 minus 3 gets me 2. And now we're going to bring them all over. My restrictions right now are x cannot equal 3 and negative 5. So I subtract 2x. I subtract 2. So I've got x squared plus 4x plus 3 equals 0. So multiplies to 3, adds to 4 is 3 and 1. So when I do my ZPP and solve it, I get x equals negative 3 and negative 1, which it can equal both of those, so we are good. Okay, I'm going to throw this negative up top. Boop. Remember, I like these in the correct order, so I'm going to flip-flop them, keep that negative with it. And then I also don't like when there's a negative, so I'm going to keep him and take him out and flip all those signs. Now these negatives on top and bottom cancel. So really what this represents is a 1 over x minus 1 to make it a little bit easier. So I'm going to take him out and put my 1 over x minus 1. Because I had a negative on top and bottom when I took him out. Two negatives cancel and make a positive. So let's figure out what they share. So I'm going to have to factor that center one there. So multiplies to negative 4 adds to 3 is going to be 4 negative 1. So it looks like my left side's missing x minus 1. My right side over here is missing x plus 4. So when I multiply by 1, it's the same. I got that 2 plus. Multiply by 1, it's the same. All my bottoms cancel. If I bring my x over, my x's cancel. So when I get negative 1 equals, that gets me 6. They will never equal. So this is going to actually be no solution because my x's canceled and those don't equal each other. Okay, my next one here, he's missing b plus 2, he's missing b minus 2, and he's missing b plus 2. You gotta make sure you multiply by that entire top. That's why I'm putting them in sets of parentheses. So when I FOIL this one, I get b squared minus 2b minus 8. When I FOIL this one, I get b squared minus 4b plus 4. And then multiplying that by 1, he stays the same. My bottoms cancel. Remember, only in equal signs. When I subtract my b squareds, they should cancel. Let's go ahead and combine like terms to see what we got on that right side. So negative 4b plus b gets me negative 3b. 4 plus 2 gets me 6. So let's go ahead and add that 3b over. And in the same step, I could add the 8 over to the other side here. So I get b is equal to 14. Let's double check. My restrictions, b cannot equal 2 or negative 2, so my 14 is good. Alright, my next one, we got some foiling. Let's bump that negative up. So I've got 4x squared, multiplies to negative 9, adds to 0 is 3 and negative 3. So plus that negative 2x over x plus 3 equals 3 over x minus 3. So it looks like everything's good on that left part. He's missing x minus 3 and he's missing the x plus 3. So I'm going to get a 4x squared minus 2x squared plus 6x when I distribute him equals 3x plus 9 when I distribute him. So that's going to get me a 2x squared plus 6x is equal to 3x plus 9. I've got x squared and x, so we're going to bring it all over to my x squared side. So I'm going to subtract 3x. I'm also going to subtract that 9. So 2x squared minus 3 plus 3x minus 9. And then we factor, so I got to send that 2 back. 3. So minus 18. So multiplies to negative 18, adds to 3 is a positive 6 and a negative 3. I sent a 2 back. I now need to divide by that 2. So I would get an x plus 3 at 2x minus 3. When I do my ZPP property, I get x equals negative 3, and I would add 3, divide by 2, so 3 over 2. Let's double check to make sure I'm good on that. This, I get x cannot equal negative 3, which was one of them. So I actually need to cross that one out because it does not work. Okay, my last one here. Oops. We're going to bump that negative up and make sure you bump it up to the z and that 6. So it looks like this is missing z minus 2. He's missing z minus 2 and z plus 2, or plus 1, and he's missing z plus 1. So I'm going to get a 4z plus 4. When I FOIL this, I get a negative z squared plus 2z minus 6z plus 12 equals, when I FOIL this side, I get a z squared minus z minus 2. All right, let's go ahead and combine some things here. All right, so I could add this z squared over if I wanted to. Oh, come on. So that he's gone right here. And then I could combine these as I'm doing that. So 4z and 2z and negative 6z. So 4 plus 2 is 6 minus 6. They all cancel. So then I really just have 4 plus 12, which is 16, is equal to, I added that z squared over. I'm going to subtract that 16 over there. So 2z squared minus z minus 18. Okay, and this one we actually have to use quadratic formula for. So x equals negative b plus or minus the square root of b squared minus 4ac. And the answer you are going to get is going to be this, but you won't see this happening on the test. That's not a decimal, that's a 145. Let's fix that. Which is pretty ugly.